Hi everyone, today we're going to be going over how to solve 3 linear simultaneous equations. If you've seen my video on how to solve 2 linear simultaneous equations, then it's a very similar method, except we just have an extra step involved really, but it's all the same principles. So step 1, we always label the equations so we know which one we're talking about at a given time. And now we've got to choose what letter we want to get rid of. So I would often choose the one that has the easiest common multiple. So in this case, it's going to be the y values. And we choose 2 equations that we can eliminate the y values from. So I'm going to choose equation 1 and equation 2 to begin with. So equation 1, and we don't need to change them because they're both y values anyway. They're the same order of magnitude. So 2x plus y plus z equals 8, and equation 2 is 3x minus y plus 2z equals 17. And we've got to go, okay, do we add or subtract these equations to get rid of the y's? Well, if I do y plus minus y, then that's the same as y minus y, which gets rid of our y's. So we add them. So 2x plus 3x is 5x. Our y's cancel, and z plus 2z is 3z. X plus 17 is, 8 plus 17 is 25. That's our equation 4. We're going to label it because it's still got 2 unknowns in it, so we can't solve it just yet. Now we choose either 1 and 3 or 2 and 3 to eliminate the y's again, so that we get another equation in terms of x and z. So I'm going to choose 1 and 3. But we've got to multiply equation 1 by 3 in order to get that to be 3y and that 3y, so we can eliminate them. So that'll be 6x plus 3y plus 3z equals 24. And equation 3 we just leave as it is. So we have 4x plus 3y minus 3z equals minus 10. 3y minus 3y is going to give 0, so we want to subtract them to eliminate the y's. 6x minus 4x is 2x, the y's cancel. 3z minus 3z is 3z plus 3z, which is 6z. And 24 minus 10 is 24 plus 10, so that's 34. That's our equation 5. And now we have 2 equations in terms of x and z. So we do, now it's just basically the same as our 2 linear simultaneous equations. So we decide, do we want to eliminate z or do we want to eliminate x? So I'm going to eliminate z here because I can multiply this by 2 to give 6. And then we can just add or subtract it from that to eliminate the z's. So equation 4 times 2 is 10x plus 6z equals 50. And equation 5 stays as is, so that's 2x plus 6z equals 34. So then 6z minus 6z is going to cancel the z's out, so we subtract the 2 equations. And 10x minus 2x gives us 8x, those cancel. 50 minus 34 is 16. So that means x equals, and if we're bringing 8 over, then it's multiplied here, so we divide it on the other side. So that's 16 divided by 8, which is 2. So now we've got our value for x. Then we basically do the reverse as we go back up. So we put it either into equation 4 or equation 5 to try and get z. So I'm going to put it into equation 5. So 2 times 2 plus 6z equals 34. So that's 4 plus 6z equals 34. 6z equals 30, and z equals 5. Now I've got a z value and an x value, so we can put it back into either 1, 2, or 3 and find y. So I can put it into 1. I'm just going to do it over here for ease. So equation 1 was 2 times 2, which is 4, because we're putting our x value in over here, plus y plus z, which is 5, equals 8. So now we have 9 plus y equals 8. So y equals -1. And you can put all of those values back into your equations to make sure they're correct. And we would find out, thankfully, that they are. And yeah, that's how you do it. One of the tips I'd always say is make sure whenever you're multiplying your equations, say like multiplying equation 4 by 2, that you multiply the entire equation by 2, because sometimes people seem to do it on this side of the equation and then they put the equals in and they completely forget they need to do it for this side of the equation as well. As long as you multiply a whole equation by just a number, it's still the same equation, it's just got bigger numbers in it. But if you only multiply parts of the equation by a number, then you've completely changed the equation. It's something completely different. So yes, I hope this helped. Thank you for watching, and good luck with your questions.